Hey everyone! Today, we're going on an adventure to learn about Isaac Newton, a super smart scientist born way back in 1643 in England. This guy was a total genius who changed how we see the universe. Newton wasn't just into physics. He loved math and outer space too. He made awesome discoveries in many areas, but he's most famous for his physics work. His most popular book, Mathematical Principles of Natural Philosophy, is like the Bible of classical mechanics. Basically, it explains how objects move and work together in our world. Before Newton, people didn't really get how things moved, but Newton used math to explain why things move the way they do. It was a huge deal for science. His work is super important for modern science. Newton also made big discoveries about light and gravity, but most people remember him for his laws of motion. These laws help us figure out how things will move and work together. They're super important for our everyday life and all the cool technology we use. If you're curious about science, you gotta understand Newton's laws. They help us understand even more complicated stuff. Even today, we learn about these laws in school and use them to build amazing things. Newton's work still shapes science today, proving that his discoveries are timeless. Okay, let's talk about Newton's first law of motion. It's got a fancy name, the law of inertia. Basically, it says that if something is still, it will stay still. And if something is moving, it will keep moving in the same way unless something else pushes or pulls on it. Imagine a book just chilling on a table. That book is going to stay put unless someone moves it. It won't magically start moving on its own. This law helps us understand why we need to use force to move things. If you want to slide that book across the table, you have to give it a push. Your push is the force that changes how the book is moving. Now, imagine a ball rolling on the ground. It eventually stops, right? That's because things like friction and air resistance are pushing on it, making it slow down. We see inertia all the time in our daily life. Ever been in a car that suddenly stops? Your body keeps moving forward, right? That's because you were moving with the car and then the seatbelt had to stop you. Understanding inertia helps us make cars safer with things like seatbelts and airbags. Inertia also explains why it's hard to stop a big truck. The heavier something is, the harder it is to change how it's moving. That's why big trucks need a lot of space to stop compared to small cars. Time for Newton's second law of motion. This one explains what happens when a force acts on something. It says that how fast something speeds up or slows down depends on two things: how strong the force is and how heavy the object is. There's even a formula for it. F equals sign may. F is for force, m is for mass, how heavy something is, and a is for acceleration, how much it speeds up or slows down. Picture yourself pushing a shopping cart at the store. If you push harder, the cart goes faster. That's because you're increasing the force, which means more acceleration. If the cart is empty, it's easier to push and make it go fast. But if it's full of groceries, you need to push harder to get it moving at the same speed. This law is super important for understanding how things move. It tells us that heavier things need more force to move the same distance as lighter things. That's why it's way easier to push an empty shopping cart than a full one. The heavier something is, the harder it is to change how it's moving. Even athletes use this law. Think about a soccer player kicking a ball. The harder they kick, the faster the ball goes. Understanding this helps athletes get better at their sport. Newton's second law isn't just something you learn in school. It's used to design cars and machines. Engineers use it to figure out how much force is needed to make things move or stop safely. Let's dive into Newton's third law of motion. This one's super famous. For every action, there is an equal and opposite reaction. Basically, forces always come in pairs. Push against a wall and the wall pushes back on you with the same force. Sounds weird, but it's how things work. Imagine jumping off a small boat onto a dock. When you push down on the boat to jump, the boat moves away from the dock. Your push on the boat makes it move in the opposite direction. This happens everywhere, from walking to launching rockets into space. When you walk, you push back on the ground with every step. The ground then pushes back on you with the same force, making you move forward. Without that reaction force, you just slip and slide. This law isn't just about walking. It explains how cars, planes, and even rockets work. Newton's third law is how we launch rockets into space. When the rocket's engines fire, they push hot gas down. This makes the rocket go up with the same force. Understanding this law helps us design all sorts of cool technology, from simple tools to complex airplanes. It reminds us that every action has a consequence, which is true in physics and in life. Newton's laws of motion aren't just old ideas, they're super important for understanding how our world works. They explain why things move and help us explore even more about science. These laws are everywhere, from building bridges to launching rockets into space. We use Newton's laws every day, even without realizing it. When you drive a car, play sports, or even just walk around, these laws are at work. They help us predict what will happen and stay safe. These laws are still inspiring new ideas and inventions today. We use them to create amazing machines, build faster cars, and explore outer space. If you're into science and engineering, you definitely need to know Newton's laws. Understanding these laws helps us appreciate how incredible our world is. As we keep exploring and creating new things, Newton's laws will always be important tools for understanding the universe. Isaac Newton's work changed the world, and his discoveries are still making a difference today.